everyone, I hope you all are good and you all are practicing problems. Let us for now solve this one. So in this question, we have said that there is a small satellite of mass m and this is getting launched into an orbit of planet and that orbit is of radius r. Okay? And satellite is getting launched into this orbit. So how we launch the satellite? A little idea if I give you, then it is like, suppose you have a satellite, you give it calculated amount of energy. Okay, you supply it with calculated amount of kinetic energy so that it can reach up to this height and it can reach to a point in this orbit. And if it managed to reach here with such a value of velocity which is equal to the orbital velocity, then what will happen? Then because of this gravitational pull, it will stay in this orbit because for this orbital velocity thing, this gravitational pull will let it go around in a circle. Okay, so this is how we do it in short. But let us move ahead in this question. Question में क्या कह रहा है? We have to calculate the kinetic energy of this satellite if we know its angular momentum, and that is given as J. ठीक है? So let's say here is velocity is v. So velocity vector will be like this. What will be the angular momentum thing? Angular momentum आप कैसे लिखते हो? आप लिखते हो r cross mv. ठीक है? So here r is this, mv is this, right? Angle between r and mv is how much? 90 degree. So magnitude wise, it is RMV, sine 91, right? And what will be the direction? R cross MV. So it is anti-clockwise. If you see here, suppose body has reached here. And here, if you write the velocity vector, that is momentum vector, write it carefully. And then again R vector. If you calculate angular momentum around P, again, it is R cross mv. So again it is in anti-clockwise direction and r is r, mv is mv. Because velocity magnitude is not going to change, because when you launch a satellite into the orbit of planet, and if you're only talking about force acting on satellite because of planet, that force is acting towards the center. And this force is responsible for taking this satellite into the circle thing, right? This force has no component along the tangent. And so if along the tangent there is no force acting, velocity ka magnitude is not going to change. Only direction because of this central force. Done hai? So this is a case of uniform circular motion, right? So v value will remain constant. So mv, that is momentum ka direction is changing, magnitude is constant. So here also r and mv ke beech ka angle 90 degree hai, r ka magnitude same as before, mv ka magnitude same as before, angular momentum is same, both in magnitude and direction. So angular momentum is not changing. And why it is not changing? Because angular momentum change when external torque acting is not equal to 0. And here only one force is acting which is passing through point P, and its torque around point P will be 0. So external torque is 0. And if that torque is 0, I mean its angular momentum about P point is going to be conserved. Okay? So J will be constant basically. And it can be written as RMV. From here you can calculate velocity. So that is equal to J by MR. And now you can calculate what? Kinetic energy. So half mv square, and that is equal to half mj by mr ka whole square. So this is equal to j by 2 mr ka square. So this is going to be your answer. I hope you have understood this question, but if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.